Good morning everybody students. See that up to the last video for this chapter that is the trigonometric function, we already see that. So that is the relation between the polar coordinate and Cartesian coordinate. Now today we see that the new article, that is the rules. So there are rules in our syllabus, that is the sine rule, cosine rule and projection rules. So first of all we see that the sine rule. And so what is the sine rule? That sine rule will be depend upon the triangle. Suppose that I will consider the triangle. Otherwise suppose that this direct theorem is there, and this is the important theorem for the syllabus for the exam. Suppose that this theorem will be like this: the sides of a triangles are proportional to the sides of the opposite angles. Means that if you consider that triangle ABC, so their opposite sides are in this arc theorem is given that is suppose that the capital A, B and C are the measures of the angles of a triangle ABC, and that small a, small b, small c are the length of the opposite sides to the corresponding angles A, B and C. Then the sine ratio of this angle, that is the sine A, sine ratio of angle B, that is sine B, and sine ratio of angle C, that is the sine C, are proportional to this opposite sides, to the sides. So that is A upon sine A is equal to B upon sine B is equal to C upon sine C. So we want to prove this, and so that's why it needs. So first we start the proof. So it needs the figure first. So see that is figure. I will consider this is the x-axis and y-axis. At the origin, I will take the point O, and this point B on the positive x-axis, and the point C is above the x-axis. Then you get here triangle ABC. So this point A is at the origin, that's why its coordinates are definitely 0, 0. And now this length AB is the opposite angle of the opposite side of the angle C. So that's why its length is C. And this point B is on positive x-axis, so that's why its y coordinate is definitely 0, and its x coordinate will be the C. And so that's why the coordinate of point B is the C, 0. Okay, now this point B is the in first quadrant now supposed to be here in quadrant, and this is the angle A. This is the angle A, and this length is capital small b, because this is the opposite to the angle B. So by definition of trigonometric functions, we define here the coordinate of point C as a B cos angle A, comma B sin angle A. That is by definition of trigonometric function in our last year syllabus. So by the way, we get all the three coordinates of these points. After this, so you consider this triangle, that is the triangle AMC, like this triangle AMC. According to our definition of sine ratio, so that is the opposite side upon hypotenuse. So I will consider angle A is here. And so sine of angle A is equal to length opposite side, that is the length CM, upon hypotenuse, that is the B. So that's why I write here sine A is equal to length CM upon B. And so therefore length CM is equal to, that is the B into sine A. I will consider this is the equation number first. Again I will slightly change in this figure. Suppose that instead of point A, I will consider the point B as a origin. So I will shift this triangle to this side, second quadrant side, and so that's why this is the figure. I will shift the figure. This is that B is at origin. Then definitely point A is along the negative x-axis, and this point C is above that is the side AB, otherwise above the x-axis. So therefore the coordinate of point B is as a 0, 0, because it is at the origin. Now this side AB is opposite to the angle C. That's why it is the small c. And therefore this point A is lies on the x-axis, so that's why its y coordinate is definitely 0, and its that is the x coordinate will be the negative c, that is the minus c, 0. Again, see that this angle, acute angle, this is the B, but this angle will be the pi minus b. And so again by definition of direct triangle and standard trigonometry functions, so like this is the positive x-axis, this is the like this. So that this is the direct triangle like this. And so the point this angle is point phi minus b. So that's why coordinate of point C will be defined as, that is the a cos of pi minus b and a sin of pi minus b by definition of trigonometric function. We know that angle pi minus b, this length is a, and so that's why that will be definition, that is just like r cos theta and r sin theta, just like the theta will be the pi minus b and r is the a. So that's why this coordinate of this point C will be a cos pi minus b and a sin pi minus b. So by simplifying this by using the aligned angle formula, so we get that this is the quadrant second. In second quadrant, that cos ratio is negative, so that's why we put here negative sign minus a. And so this is the measure along the x-axis, that's why this ratio cannot be changed. So that's why cos of b and its negative value. So that's why we get minus b cos a. Here pi measure that along the x-axis. So that's why don't change this sign, this ratio, that is the sign it is as this part attached angle b. So we get the sin b, and that is a is already there. And see the observe the quadrant is second. In second quadrant sign ratio is positive. That's why it is the positive. And so therefore by this figure, so you get actual coordinate of point C will be, that is the minus a cos b comma a sin b. I will consider this is the as. Okay. Again after this, I will consider this triangle, that is the triangle CMB. Otherwise BMC. In this triangle, angle B is the acute angle, and so I will consider this angle and define by definition of sin ratio, that is the opposite side upon hypotenuse. So that's why I will get that length CM upon A. Length CM upon A. By simplifying this, we will get the length CM is equal to A into sin B, that equation number second. And so therefore from this first equation and second equation, because both are the values of the length CM, so I will compare their left right hand side. So we get that is the B sin A is equal to A sin B. Again simplify this, so I will get that A upon sin B is equal to B small b upon capital small B. I will consider this is equation number second. Similarly, I will consider again this position of point C is here at origin. Here at origin, point B is this side. Then you same way simplify. So we get similarly we can do the next thing, that is the B upon sin B is equal to C upon sin C. I will consider this equation second, and by comparing the both for third and fourth, so we will get that A upon sin A is equal to B upon sin B is equal to C upon sin B. This is called sine rule. This is called sine rule, and hence it is the rule. So this is the theorem, and we afterwards we see the some example taken on the theorem. Okay, thank you.